I'm trying to do that, but it's
Please
not
begin.
happening.
Okay. Hello, good morning everyone, and thank you for joining today's webinar. Today we have scheduled webinar on dairy industry, its manufacturing and processing, which has been organized by Applied Sciences and Humanities Department of Parul Polytechnic Institute, Parul University. I, Vaishali Nathwani, would like to introduce today's guest speaker, Varsha Biswal. She has completed her MTech in Biotechnology from KIIT Bhubaneswar. She has done mini projects on environmental pollution from hazardous waste disposal and health effects. She has received Junior Research Fellow in the Science and Technology Department from the Government of Odisha funded research project. She has been qualified for PhD at Utkal University Bhubaneswar and now currently working as Chief Executive Officer at Trustee Dairy, Odisha, India. She is also interested in writing poems, painting, making of mandala art, dancing, and have also received various awards in their respective fields. Her aim is to become an entrepreneur and along with it to work into one of the prestigious and renowned research labs of the country. It's a privilege to welcome you here, ma'am, on this platform.
Hello. Thank you so much for having me here. And namaste and Jai Jagannath. So this is Varsha Biswal, CEO Trupti Dairy. So I'm here to present a total scenario or exaggerate the total scenario of a dairy product or a dairy industry. So first of all, I want to say something about total scenario is that dairy industry have shown tremendous effect or in the total country, like in total country or in the total worldwide, the dairy industry have given a very powerful impact. So milk and milk products are very essential part of our daily basic life, and everyone or the other have milk products, and we use milk products on daily basis. So have you ever thought like how the milk chain are being introduced, how the milk has been collected, then manufactured and processed? There is a very uh, large or very strong process of maintenance chain, processing chain, yet production chain. So a huge amount of milk is first being collected from the milk farmers. Then what we do is we see whether the milk we have collected is good or not. Like what the farmers do is like they add some salt or some baking soda or all sort of adulterant to increase the consistency of the milk. So to check that whether the milk is totally good or not, so we go for this tasting process. The tasting process we go is chemical testing and microbiological testing. In chemical testing, what we do is we test the acidity level, we test the salt, we test the sugar content, carbohydrate content, hypochlorite content. Then we go for MBRT, methylene blue test. Then we go for so much of microbiological tests, such as we do serial dilution, then we go for plating, then isolation of bacteria, then staining to see whether uh, the thing containing, like whether the milk have gram positive or gram negative bacteria or not. Then we go for antibiotic test. So let me explain you how we collect the milk from the farmers till production to distribution to the customers. First we do is we collect the milk from the farmers. Then we go for the test. If we see that the test result is positive of the raw milk, then we go for further manufacturing production. Here, what we do is we collect the milk. When we collect the milk, we keep it in a cooling chamber. We keep it under 4 degree so that it will not get damaged or will not get form any clottation. So here, what happens if the milk stays outside uh, after for 2 hours, then it can stay properly. If it exceed beyond 2 hours, it start forming clottation or it start forming damage. So the milk get totally degraded because it is very perishable in nature. So it can stay outside only for 2 hours. Either it be a raw milk or the value added dairy product. So then we'll go for dairy processing plant. So what we have two categories of it. First is fluid milk processing. Here what we do is it involves pasteurization and processing of raw milk into liquid milk for direct consumption and its byproducts such as cream, paneer, buttermilk and yogurt. So basically we can say is this is we bring the milk from the farmers and we boil it on a gas stove and we have it, or we do it we use it for various production of byproducts homely. So industrial milk processing, here what we do is we collect the raw milk. It involves pasteurization and processing of raw milk into a value added dairy product such as cheese, butter, paneer, milk powder, condensed milk, whey proteins, ice creams, and other frozen dairy products. So here in industrial base, it is a very challenging process so as to keep the temperature of the milk contained to 4 degree, and starting from collecting of the milk, keeping that similar temperature till it reaches to the factory site. We keep it at 4 degree. So that is very challenging for any kind of milk, any milk industry factory. So as I said, we go for chemical testing so as to check the consistency of the milk, so as to know whether they have added some preservatives or adulterant to increase its consistency or not. So there are various methods to test the milk through chemicals, like clot on boiling test, alcohol test, acidity test, hydrogen peroxide test, hypochlorite test, and so on. Then I'll go for microbiological test. So numerous tests and samples are collected to analyze the presence of microorganisms. What we do is we collect the sample, we go for serial dilution. After serial dilution, we we plate those sample on a petri plate, then and keep it for incubation. Next day, we collect those isolate a cultural bacteria. Then we go for staining procedure to check whether the milk or any kind of food product or any stuff containing gram positive or gram negative bacteria or not. Then after that, we go for antibiotic test. Antibiotic test is done to treat an infection. Secondly, to see which pathogen is sensitivity to chemotherapeutic test or chemotherapeutic agents. Then we go for standard plate count where we count all the colonies and then we take the colony forming unit like we totally count the bacterial colonies formed in the petri plate. Then we calculate its total amount of the bacteria presented in the milk. Then I'll go for the total flow chart. Uh, First, what happened? Raw milk is lacteal secretion, partially free from colostrum, obtained by completely milking of a healthy cow. So, temperature should be maintained for 4 degree, and that should be kept within 2 hours, because after 2 hours, if we keep in a room temperature, then it will start forming clottation, like as I said before. Then a bacterial standard count of a raw milk is more than 1 lakh colony forming unit per ml. So, and the somatic cell count is more than 7 lakh 50,000 colony forming unit. And the antibiotic presence sometimes it is negative. And the storage time at the plant is maximum 72 hours. If kept longer time, it will allow the growth of cyclophilic bacteria, which can secrete heat-resistant proteases and lipids, which can create problem during pasteurization. What happens is when there's a specific time limit for everything. Let it be collection of milk, let it be pasteurization, let it be homogenization, let it be anything. There is a specific time limit for everything. If we don't do our work within that specific time limit, the milk bacteria present in that will start get resistant to a specific temperature, to a specific environment, to a specific unit. So what we do is we have to do everything within time. It cross that time limit, then it will start forming degradation, and it will not get degraded when it is being pasteurized, because pasteurization is the process in which we kill the growth of the pathogenic bacteria or fungus. This is the main motto of pasteurization. So then we go first raw milk collection. Then we go for cleaning, clarification, and separation of the milk, homogenization of the milk, fat standardization, heat treatment, chilling and cooling of milk and milk byproducts production. Then we go for storage. Then we go for filling and packaging. So let me tell you the thermalization of milk. Thermalization of milk is a sub-pasteurization heat treatment of milk. It at 62 to 65 degree for about 10 to 20 seconds, and then it is kept under refrigerator. It is effective when cooled to 4 degree after treatment. Applied to raw milk that needs to stay several days prior to use. The main purpose of thermization of milk is to reduce gram-negative spoilage bacteria or organism. Then we go for clarification and clearing. Here what happens, clarification and clearing, it ensures further standardization of product, avoiding any kind of damage to the product. But here what we do is, in clarification process, we go for centrifugation, separation, and clarification. It is a very common in a dairy processing unit. So what happened? Here we remove small particles such as some hair, straws, pebbles, etc. from the milk if present. So then we go for bactification. In bactification, what we do is we go for centrifugal separation of microorganism from the milk, because what happens, some of the microorganisms stay in the milk. So as to reduce that amount of microbial load, we go for bactification. In bactification, the bacteria, actually what happens, the bacteria and spores have higher density than milk, and spore load reduction can be like spore load can be reduced here in this process up to 99% by using two-stage centrifugation. 55 to 60 degree is the optimum temperature for clarification of any clarification for separation and centrifugation of any milk product. Then we go for microfiltration. In microfiltration, what we do is uh, the membrane used in microfiltration should have the size of 14 micrometer, which can lead to reduction of bacteria and spores up to 99%. Then we'll go for milk fat standardization, where it what happens here is the centrifugation used and the centrifugal separation used in this process. Separation of skim milk and cream mostly used in this milk fat standardization method. Commonly, what happens, cream has lower density than skim milk, and standardization of fat content is that adjustment or maintaining of fat content of the milk or the milk byproducts done by addition of some amount of cream or skim milk to obtain a given fat content. So basically what we do is we take a small amount of fat from the milk and we add it to a skim milk to obtain a given parameter of the fat content should contain in a value based dairy product. Then there is a term called SNF. SNF means solid non-fat, which means the milk which doesn't contain any amount of fat. Like for example, it contains protein, lactose, and the total amount of solid except the milk fat. The amount of butter and the SNF can vary because of the breed from where the milk has been collected, feed supply, and the time of the year. Like time of the year means the period at which a cow uh, undergoes lactation. So then we'll go for homogenization. In homogenization method, here what we do is it is a process in which we reduce large fat globulous molecules of a milk into extremely small particles and distribute it uniformly throughout the fluid milk, where the milk is forced through a narrow small passage at a very high pressure or a high voltage or velocity. When the milk is properly homogenized, the cream present will not rise to the top, because main focus of homogenization is to reduce the fat content from the milk. Because in dairy based industry what happens, we have different kind of milks, like we have skim milk, we produce tone milk, we produce like what like low fat milk, homogenized milk. So depending upon the parameter of fat percentage of the milk we produce, we have to do that kind of production as per the requirement of the customers. So benefit of homogenization is it gives milk a rich and white color yet a smooth texture. Meanwhile, it increases the shelf life and better taste and better mouthfeel. So it performs multiple functions such as breakdown of particle size, dissolution, mixing, dispersion, encapsulation, and emulsification of the total functioning. So this is most effective when fat phase is in liquid state, like when milk has contained a huge amount of fat, and when the 12% fat, if the fat percentage of the cream is less than 12%, can't be homogenized in a normal temperature. It has to homogenize in a higher pressure homogenization. So basically, milk have 150 calories. Like it contains total calories of 150. So out of which uh, 5 gram is carbohydrate, 8 grams is protein, and 8 grams is fat. So total cow milk contain 8 grams of fat, which is about 4 to 5% of fat. And skim milk contains 0.5% fat. Then we have reduced milk, low fat milk contains 2% fat, and so on, depending upon the customer need. And tone milk also like that, like it contains 2% of fat. So what we do is like then all the fat should be within 8.25% according to the Fasai rule. The fat percentage of the milk should be between that only. If like yeah, because we have a specific parameter for each milk we are producing, starting from the tone milk to a fat milk to a skim milk and a reduced fat milk. Then I'll tell you about I'll tell you something about pasteurization. So pasteurization is the process I said where to remove or kill pathogenic bacterial formation and uh, growth as well, so as to
Hello.
hello, hello, okay, hello. Mhm. So sorry for the interruption. I'll tell you about pasteurization process. So as I said before, like pasteurization is a process in which we kill the pathogenic bacteria or any kind of fungal growth in the milk. So the temperature maintained in pasteurization is for 72 degree for 15 minutes, and if it continues for 30 minutes, the temperature should be kept between 63 degree. And sometimes what happens, it doesn't kill any vegetative cell bacteria, and its temperature is continuously recorded, and the milk is immediately cooled below 40 degree, because like as I said, like after collecting the milk from the source till production to distribution throughout, we have to keep any kind of milk and its milk product in a 4 degree environment, because as it is perishable in nature, it will start forming clottation and get damaged. So immediately after pasteurization, we have to cool the milk below 4 degrees. And pasteurization in 1938, when milk born outbreak was 25% on that time. Like I'm talking about 1938 time. But now the milk, due to the various technology introduced in the dairy industry, the pasteurization of due to the pasteurization itself, the milk outborn or outbreak disease have reduced to 1%. From 25 to 1% is a huge difference. Like you can understand what I'm saying and what I'm telling about. Like it's thanks to the technology, thanks to the science, for which we have got so much of so much of what I'll say advantage of introducing any innovative stuff for better India or better world. So heat treatment, which come under pasteurization. Here, what we have two type of pasteurization. What is that is an ultra pasteurization. Another is ultra heat pasteurization of milk. Here, what happened in ultra, both are pasteurization technology. The ultra pasteurization milk, these are non-aseptically packed, and ultra heat milk, these are uh, aseptically packed. These are non-aseptically, the UP, like the ultra pasteurization, and the UHT, the ultra heat pasteurization. That milk are aseptically packed. And what happened? The UP milk, they are immediately refrigerated, and the UHT milk, they are stored at room temperature so as to avoid any kind of contamination. And there are different standard, like we have a bacterial count for a A grade pasteurized milk and milk products. The bacterial count should be is more than 20,000 colony forming unit per ml. Then we have coliform count, where it is more than 10 per ml. And we have phosphatase count, which is more than 1 microgram per ml. An antibiotic present in this A-grade pasteurization milk and milk product is negative. And when now, if we come to ultra heat processing of the milk, here what happened? Here the bacterial count is not present. Like, we don't see any kind of bacterial growth in this phase, and antibiotic presence is negative. So we have a specific standard for pasteurization according to a government rule or government certified rule. Here, what we do is, like, we have a pasteurized milk ordinance, which is called PMO. So here, what happens? Uh, there is a parameter set by the Public Health Service, or you can say a Food and Drug Administration department. They check the sanitary regulation of milk and milk products. Here, the main purpose is to keep a specific sanitation measure throughout the production, handling of the milk, pasteurization of the milk, and distribution of the milk. So you can say that it goes through from the production till distribution of the milk. So there are some bacteria that limit shelf life. As I said, like, we have specific time limit for each and every process. Let it be homogenization, let it be collection of the milk, let it be pasteurization. There are some lipolytic or proteolytic cyclotroph bacteria that are heat resistant enzymes. For example, we can say Pseudomonas lawrence's, and there are heat resistant spores also. For example, Clostridium bacteria, Enterococci. and bacillus, etc. These are some of the bacteria that can cause disruption or that create problem during the production or the process. So what that's why we go for pasteurization in within that 72 hours. If we cross beyond that time limit, they will start forming that resistant property. And in that time, it will be very difficult. And milk industry is a very challenging industry. Like you have to be very specific, you have to be very alert because any little problem, any little um, like mind distraction will lead to a disastrous product. So now I'll tell you about fermented dairy products. In fermented dairy products, what we do is we transfer a biological source. Biological source we transfer is essential bacteria or fungus. We collect the essential bacteria and fungus. We introduce in a food product so as to produce a good fermented product. And the characteristic of this fermented dairy products are a breakdown of carbohydrate such as lactose to lactate. These products are preserved. A very interesting part. This is a very interesting part. I love this like technology of science. These fermented products are preserved by the production of acids and alcohol by the beneficial bacteria fungus we have introduced to inhibit any kind of spoilage bacteria and pathogen. For example, the fermented products are like cheese, curd, whey, and etc. Now I'll tell you something about milk powder production. First, what we do is we collect the standardized milk, then we preheat the milk. Before drying the milk, the standardized milk, we first preheat the milk with the help of a tubular heat exchanger. Then we go for evaporation process. In evaporation process, what happens is we the milk we have collected is passed through evaporator so as to increase the concentration of the total solid. Then to maintain that level of total solid depends upon the efficiency of the equipments that are being used in the total dairy setup. And secondly, the amount of heat we are generating for that maintenance that should not disturb or damage any kind of milk protein within that process. Then after that, we what we do is we pass that milk concentrate or milk solid through a atomizer of a drying chamber where the milk is being dried and it forms like a fog like mist like structure, and it's been rapidly uh, heated, like passed through a hot air steam, where the milk is the individual mist droplet of the milk is immediately or instantly evaporate so as to form a milk powder. Then after everything is done, we collect the milk powder. Then we we separate it from the chamber. Then we keep it in a cyclone separator. Then after all this process, we go for feeling and packaging of the process. Here what we do, the benefit of packaging is it enables the efficient food distribution, it maintains the hygiene of the product, and it reduces food spoilage. And the packaging should have the product detail or product information. And different containers we use is glass containers, plastic containers, cartoons, and plastic bags. Then we take care about the shelf life of the milk. Shelf life, as I'll say that it is a time for which a product can be stored without quality falling below a certain acceptable minimum level. To extend its shelf life, which is termed as ESL, here what we do is a customer basically can consume pasteurized packet milk for 5 days under refrigerator condition and other variety of milk products for about 14 days to 1 month, depending upon the date of manufacturing. Generally, it involves measures to eliminate or minimize the post-pasteurization contamination. Then, the shelf life of heat treatment of the fluid milk depends on the raw milk quality, processing condition, and post-processing storage. Here, what we do is we should be very careful of the packaging system because the test and vitamin gets degraded if exposed under the sunlight. So the light is impermeable containers are used. The light impermeable containers are used to avoid such kind of damage. So at I'll conclude the slide or conclude my presentation by telling the total scenario of the Odessa milk industry. Currently, our state represents the fourth largest dairy market in India. The milk production in Odisha mainly consists of cow and buffalo milk. The report analysis concludes that cow milk dominates the total milk production, counting for the major total production of the entire milk unit. And the liquid milk is the biggest milk production in the unit. And we have different kind of products that we produce is rabdi, sweet curd, buttermilk, and lassi. According to the study, there will be a 14% increase in the total dairy industry in our state starting from 2021 to 2026. So there will be a very huge amount of uh, dairy industry growth in Odisha as per the study we have collected from the source. So this is my interview, and this is my talk about total dairy industry. Thank you, and I'm concluding this slide now. Hello, hello,
Hello.
hello.
Yes. Thank you so
Yeah,
much.
yeah. Hello. Okay. Hello.
Hello. Is
Yeah,
it audible?
hello. Hello.
Hello. Am I audible, ma'am?
Yeah,
Now?
hello. Yeah. This time.
Okay. Yeah. Thank you so much, ma'am.
Yeah. Yeah.
Yeah. It was
Anything else you want to ask, or any questions, or anything?
yes, ma'am. There are one or two questions from our end.
Yeah, sure. Yeah, sure.
Yeah. And yes, the presentation. It was a last minute moment, but you cope up very well.
Thank you so much.
Yes.
It was a very technical problem because I got this laptop newly, so I'm little bit not aware of it. So that's why it have
No, but
created
still
a
you
disaster.
managed very well, ma'am. And without presentation, also we were able to understand the concept that you wanted to convey to us.
Thank you so much.
Yes. So, what is the main problem of dairy processing industry in India nowadays, ma'am?
Okay, it's a very good question, I would say. And the main problem we are facing is the collection of the milk. What we face is like As I said in the starting, the farmers, what they do is, due for the craving of money, they add very much of adulterant or any kind of preservative, so as to like sell their milk. So that is a very big problem, because sourcing of milk is a very huge problem, because once we source the milk, we go for testing to see whether it, like as I said, like we go for chemical testing after collecting the milk, also after the production, because to see whether the milk has contained any kind of preservative or adulterant during the manufacturing production, or we see the bacterial count that should be present inside the milk according to the FSI rule. Like lactobacillus is a very good bacteria. We can say that is a very gut friendly bacteria. It is very good bacteria that helps us in our digestion process mainly. So we go through that, like we check whether we have that particular amount of bacteria present in that or not, or we have generated any resistant bacteria, that heat resistant bacteria, like we have exceeded the time period of those pasteurization limit or not. So that's why milk collecting source is very challenging. And another challenging stuff is how you keep the milk in a cooling chamber. That cooling maintenance is very challenging, because once we collect the milk, we have to keep it in a 4 degree. If like for 2 hours we can keep it in a room temperature, but if it exceeds, then it will start forming clottation and it will damage. So that is very challenging. These two are very challenging stuff: collection of milk, and secondly the maintaining the cooling chamber, the total cooling of the milk. Yeah,
Okay. And the last question, ma'am. So
yes, sure.
nowadays, as dairy industry is also been now accommodated in academics also now, right? Because
Yeah, yeah, yeah.
last year, if you see the last year, then there was no dairy industry bachelor degree or diploma
Hmm.
degree. But nowadays in education field also, dairy industry is prospering. So according to you, is the dairy industry getting better nowadays due to education, or still there are some uh, requirements are there to fulfill?
Dairy industry have grown tremendously, I would say, because as I explained about 1938 scenario, where due to like we were not aware about so much, like in India especially, we are not so much aware about any kind of dairy setup, machineries, pasteurization method, homogenization method, and their chemical tests, microbial tests. There was not any hype of that. So that time the milk outborne disease were 25%, and now it's only 1%. I can compare with that, like how it has grown rapidly. And basically, me coming from biotechnology industry, like biotechnological field, before I was like, we collect the milk from the farmers. We like they come and give it to the doorstep, and we boil it on our stove, and we drink it, or we keep it for cuddling. We do cream, or we produce ghee from it or paneer from it. So it was like that, like before. Like now, when I got into like when I got into this field of study, then I got to know, personally, I got to know there's so much of mechanism going on, like collection of milk, keeping it in a cooling chamber. Then we go for like milk standardization of fat, and then we go for homogenization, pasteurization, packaging, peeling, and so much. Like there's so much create into it. Like yeah, and now people are also doing research on milk and its microorganisms. So I would say like now like we are we are achieving many things day by day. And in Odessa, as I said, according to the study, there will be a 14% increase in dairy industry from 2021 to 2026. So yeah,
Good. Yes. Thank you so much, ma'am, for joining with us today. The session was very fruitful for our students of dairy technology, and it would surely help them to clear their doubts. And you explained very well the from 0 point to the maximum point, the whole process of
thank
dairy industry, manufacturing, and processing. You taught us very well, ma'am. Thank you so much, ma'am, for joining with us today.
thank you so much. Lastly, I would like to say I'll be thanking HOD of this department and you, ma'am.
Thank you.
Then I would love to thank the university for inviting me as your guest speaker, and it was very much fruitful, yet very much honored to share my journey, share my industrial knowledge with you all. It was very much fruitful, yet honored.
Yes.
Thank you
Thank
so
you so much.
much.
Bye.
Bye.